Alright, so in this video I'm going to go through trigonometric equations. Now, these are very common, especially in the short questions. And the good thing about them is that you use the same method pretty much for every single one of them. There is quite a spectrum of difficulty. They tend to be very approachable. There's one question I'm going to go through that was very difficult. But most of the time, these are very doable. So, this is from last year's paper, paper 2, question 3. So x is an angle between 0 and 360, right? And cosine 2x is equal to root 3 over 2. So find all possible values of x. So with a trig equation, trig equation, is your first step is to get your reference angle. Now, for every trig equation, you will have either cosine x or sine x of something is equal to something, right? You want to take what this is equal to and get either the inverse cosine or the inverse sine of that, okay? Now, in this case, we're dealing with a cosine equation. So our reference angle is going to be the inverse cosine of root 3 over 2, right? We ignore the 2x for now. We'll get back to that later. And that'll give us our reference angle, which in this case is 30 degrees. Now, obviously make sure, right, this question we're asked for degrees. That could sometimes be in pi, so make sure that if that's the case, you use radians. And another thing to note is that for your reference angle, you always take the positive of this, okay? So if, for example, so see here, for this one where we have tan is minus root 3, right? For getting the reference angle, you ignore the minus sign. It's always the positive, okay? So that's your reference angle. Now for step 2, we're going to use what's called a cast diagram. So this is where you're using the unit circle. So if I draw my diagram, so you do a diagram that looks something like this, right? And then in that, you have, there we go. So this is my unit circle. So unit circle is just a circle where the radius is 1. Right? And you draw it in 4 quadrants like this, okay? So now you label these quadrants, right? So we label this one as C, this one is A, this one is S, and this one as T. Now, what does the CAST stand for, right? So that tells you which of your trig functions is positive in those respective quadrants, right? So in the C quadrant, right? C standing for cosine, right? So in this quadrant, cosine is positive and everything else is negative. So sine and tan are both negative, right? The A stands for all. Now this will make more sense when I carry on further, right? So all means that in this quadrant, all your trig functions are positive, okay? The S is sine. So in this quadrant, only sine is positive, cosine and tan are negative, and then your T is obviously tan. So in this quadrant, tan is positive, sine and cosine are negative. So now we look, right? So we are dealing with a cosine function that is positive, right? There's no minus sign there, so it's positive. So cosine is positive in this quadrant here and this quadrant here. So we are now dealing with these 2 quadrants, okay? Hopefully this makes sense so far. So now we use our reference angle. So our reference angle is 30. So we're going to put in an angle of 30 degrees into our positive quadrants. So that's these 2 on the left. Now, when doing these, you always go from the x-axis, never the y-axis. So we do an angle of 30 degrees from the x-axis in this quadrant, so that'll be about there, we'll say, and in this quadrant here. So that angle is 30, and this angle is also 30. Okay, I'm gonna write that out for next. I don't need that. Okay. So then step 3, we're going to get our answers. So your answer is your angle from the positive x-axis. So that is this here. So our first angle is going to be this angle here, which as we know is 30 degrees, right? Key thing now, your second angle is not this angle here, right? Your second angle is this angle. So all the way around. So that is 360 minus 30. So that is 330 degrees. Okay? So our answers are 30 degrees and 330 degrees. Now, go back to the question, right? This is the final step, right? That's cosine 2x. So we've just found that 2x is equal to 30 degrees, 330 degrees, right? If we look back at the question, x is an angle, etc. Find all possible values of x, not of 2x, of x. So if we want to get x, we're just going to divide by 2. So we'll get 15 degrees, and we'll guess 165. Yeah, 165 degrees. Now, find all values of x. So we're told in the question again, x is between 0 and 360, right? So if I add on a full rotation to my answers for 2x, right? So if I add on a full rotation to 30 degrees, right? That gives me 390. And if I add on a full rotation to 330, that gives me 690. Now, those answers are both greater than 360, so they're not valid, but that's 2x, right? We want x. So if I divide both of those by 2, so I get 195 and 345 degrees, right? I'm still within 360, so those answers are valid, right? If I add on another 360 to 390, that would be 750. But if I divide that by 2, I'm at 375, so now I'm out of the range. So my answers for x are those 4 answers there. Those are all possible values for x. Now, if you're not familiar with these questions before, that is probably quite a lot of information to take in for one part of a short question. But that method does not change, right? So I'll do a couple more and you'll see it's just the same process repeated over again, right? So hopefully then it'll start to make more sense. So 2021 paper 2 question 4. So solve the equation tan b plus 150 is equal to minus root 3 for b between 0 and 360. So we're working in the same range as last time. So we're going to do the very same again. We're going to find, first of all, our reference angle. Now, we're dealing with the tan function, and tan is equal to minus root 3. So our reference angle is going to be the inverse tan of, remember we always take the positive, so it's not inverse tan of minus root 3, it's just tan of root 3. And that is equal to 60 degrees. Now part 2, or step 2 even, we go to our cast diagram. Now, you can just draw it again. I'm just going to copy and paste it because I'm lazy. Probably should be admitting that, but anyway. And then we will paste that in here. Oh. There we go. Now, I also do not need these because they are not valid for this question. Okay. And then get rid of the ticks. Okay, so on our cast diagram. So this time we're dealing with a tan function, and we're dealing with a tan function where the angle is negative. So now we look at the negative sign. So where is tan negative? So we know tan is positive in the tan quadrant and it's positive in the all quadrant, right? So that means it's negative in the cosine quadrant and the sine quadrant, because only sine and cosine are positive in those two, so everything else is negative. So now we're going to make angles of 60 degrees to the x-axis in both of those quadrants. So that is going to be here, right? So again, where this angle is 60, and then it's going to be here. Where that angle is 60. Okay. So now we look to get our answers. So again, for our answers, we always go from the positive x-axis. So that is going to be, this will be our first angle here. And then our second angle, so that is 120 degrees. And then our second angle is going to be this one here. And that is going to be 300 degrees. So our answers, 120 degrees and 300 degrees. Now, previously we had 2x, here we have b plus 150. So these solutions are b plus 150 degrees is equal to 120 degrees, and we have b plus 150 degrees is equal to 300 degrees. Now, b plus 150 is 120, so that means b is 120 minus 150, which is minus 30 degrees. If b plus 150 here is 300, then b is 300 minus 150, which is just 150 degrees. Now, we look again at our range. Our range is 0 and 360, right? So any answers less than 0 are invalid. So this is an invalid answer, right? But again, we see if we can go another full rotation. So if I add on a full rotation, so I go around the circle again. So I go to 120 degrees and then I go around again. So I'm adding on another 360, right? That is 480. If I add on another 360 to 300, that is going to be 660. So my next answer could be b plus 150 is equal to, what did I say, 480. So that means b is 480 minus 150, which is 330. Now, if I go up to 660, 660 minus 150 is going to be what? 550. So way more than 360. So my two answers then is B is equal to, what did I say, 150 degrees and 330 degrees. And that is that question done. So small differences, but a very, very similar method. Okay. All right, 2020 paper 2 question 4. So find the two values of theta for which tan of theta over 2 is equal to minus 1 over root 3, where theta is between 0 and 4 pi. So 4 pi, so we're dealing with radians. So first things first, make sure your angle unit is in radians before you make any mistakes. So first step again, we're going to get our reference angle, which is going to be, again, we're dealing with a tan, so it's going to be the inverse tan of, so it's minus 1 over root 3, so we're going to take the positive for the reference angle, so just 1 over root 3. The tan of 1 over root 3 is equal to pi over 6 radians. And then just for drawing your diagram to make it a bit easier, that is approximately, that is equal to. Just from drawing our diagrams, that is equal to 30 degrees. So, step 2 then, we're going to do our cast. So, copy all this. And actually what I will do is I will copy this now for future questions. There we go. Okay, so in this question we are dealing with a function of tan where that function is negative. So it's going to be the very same as the last question. So tan is positive in the tan and all quadrants. So it's negative here and here, where only sine and cosine are positive. So this time we're doing pi over 6 radians, or 30 degrees from the x-axis. So that's going to be about there. So that's your 30. And then it's going to be about here again, where that's your 30. So for our answers, again, we go from, actually, what I should note is that when we're dealing with radians, the start obviously represents 0, and then a full rotation is 2 pi. 2 pi and 360 are the same. And then your halfway point, so where you would have 180 degrees, that is pi. So 180 degrees and pi radians are also equivalent. So your answers are going to be from here to here, and then from here all the way around to here. So the first bit is going to be pi. So that's going to be, let me see, pi minus pi over 6 radians. So that is 5 pi over 6. The next one is going to be 2 pi minus 5 over 6, which is 11 pi over 6. So 3 then, your answers, at least for the moment, are, what have we got, 5 pi over 6 and 11 pi over 6. Now that's equal to what? Theta over 2. So theta over 2 is equal to 5 pi over 6 and 11 pi over 6. So if that's what theta over 2 is, we are looking for values of theta So all we do is you're multiplying across by 2. So 5 pi over 6 by 2 is 5 pi over 3, and 11 pi over 6 by 2 is, I'm going to assume, yeah, 11 pi over 3. And the question only asks for 2 values, so there are our 2 values. Alright, so again, very same method, just with different numbers. So we'll do one more, yeah, so one more. Now this is difficult. This is the hardest version of this question I've seen by quite some margin, because it involves using trig identities before you even get into it. So this is from 2023, the year of the hard maths papers. So find all solutions of the following equation in t between 0 and 360 degrees. So sine t is equal to sine of 2t. Now, this was the question that I got in my exam. I was really good at trig equations and I hadn't a clue, because I was like, well, where the hell is my angle? Like, I was like, what do I get the inverse sine of? So the tricky bit here is that for this, you have to go to your log tables. If you go to your log tables on, actually I can't remember what page it is. Let me see, page 14. Let me see if I can find it, yeah. So about halfway down page 14 of your log tables, you'll see this written. Sine 2a is equal to 2 sine a cosine a. So in the context of this question, we just change a for t. So we have sine 2t is equal to 2 sine t cosine t. So now we rewrite our equation, but instead of sine 2t, we'll have this bit here. So our equation now becomes sine t is equal to 2 sine t cosine t. Now, we still have to do further manipulation. So what we want to do is we'll get everything on one side. So we'll say 0, we'll take the sine t over and we'll get 2 sine t cosine t minus sine t. So now we have a sine t in common that we can take out, or we can factorize out, I should say. So we get sine t. If we take it out of the first part, we're left with 2 cosine t. Oh, I've done this the wrong way around. So I'm looking at my solution from earlier. Will this still work out? Let me see. Let's go with it and see. So this will give me then 2 cosine t minus 1. And that's equal to 0. So we're now multiplying two factors together to get 0. So what we do now is we let what's inside the bracket equal 0 and what's outside the bracket equal 0. So we will get sine t is equal to 0, and we'll get 2 cosine t minus 1 is equal to 0. So now we solve both these individually. So sine t equal to 0. So the inverse sine of 0 is 0. So when is sine equal to 0? So if you imagine this now on your cast diagram, right? So for 0 degrees, you're going to be here, and you're also going to be here. So that is 0 degrees, right? Because the line is flat, but it's also 180, and it's also 360. So for sine equal to 0, you have 3 solutions. You have 0 degrees, you have 180 degrees, and you have 360 degrees. You have full rotation. If we start looking at 2 cosine t minus 1, so we get 2 cosine t is equal to 1 if we take it over, right? And then if we divide by 2, we get cosine t is equal to 1/2. Okay? So t then is the inverse cosine of 1/2, which is, this done here, 60 degrees. So if we put that into our cast diagram, so we have a cosine function that is positive. So that's going to be here and here. So we're going to have 60 degrees here and 60 degrees here. So our answers then are going to be this angle here, which is 60, and we're going to have this angle here, which is 360 minus 60, which is 300. So your solutions here are 600 and 300 degrees. So there you have all your solutions. So we have t is equal to 0 degrees, t is equal to 60 degrees, make sure I'm not missing anything. T is equal to 180, 300, and 360. And that is that done. That is a really tricky question. Mainly because of this first part. You would have a lot of people who wouldn't have a clue how to start that. So if you see a question this here where you're not given an angle straight off the bat, go to your log tables, go to page 14, page 13 and 14, between the two pages, see if you can make any substitutions like this, and then solve the equations from there. The equation itself, when you get down to it, is actually, well, I suppose there's two of them, they're not that tricky, but it's getting there in the first place that is quite difficult to do. So if those 4 examples make sense, you should be okay with any tricky equation that the examiner throws at you in June if it comes up. So hopefully this video has helped.